Sparks, and Tom is in the Energy and Minerals section. He'll be speaking about Class 2 wastewater injection wells in the Appalachian Basin.
Thank you for coming. The outline, we're just going to go briefly to the Class 2 brine exposed wells relating to the EPA's involvement with it. We have a few slides on the map service that we've generated from the data we received from them, and discuss about the brine disposal framework project, which just ended last fall, October. The motivation is to develop a baseline study, as we've been hearing before. This is going to be to identify and track brine disposal wells in Kentucky. The bottommost bullet indicates really what's most important about the thing is when we try to distinguish the different types of disposal wells, saltwater or enhanced carbon injection wells. It's the disposal wells that are ones that we're most concerned about for use seismicity. What are Class 2 injection wells? They're defined by EPA as a well designed to inject fluids into the underground reservoirs, or underground formations, they're usually wastewaters, brines, saltwaters, steam, flowback fluids, also now known as frac fluids. They're basically designed to, to protect the underground sources of drinking water. With the EPA, they call them Class 2 wells. They call them Type D and Type R. The Type D are the disposal wells, and Type R are what we commonly call the water flood type wells, the EOR wells or ERI wells. They actually make up about 80% of the type of Class 2 wells identified in the United States. There's about 2 billion gallons injected each day in the United States from about 180,000 Class 2 wells, 3,000 of which are in Kentucky, the bulk of which are actually the Type R wells. EPA is the primary enforcement authority for the injection control program, which regulates the primacy for Kentucky's Class 1 through Class 6 wells. If you want to get information from EPA, since you have to contact them in Atlanta, Georgia, you don't contact them directly. You get your information from through the Freedom of Information FOIA website. I've got to learn that pretty well over the last 2 or 3 years. Recently, Kentucky has actually applied for primacy for the Class 2 type wells, these disposal wells and injection wells. And the application is currently at the headquarters in Washington, D.C., and we expect the approval hopefully sometime later this year. This is just an example of some of the operations and administration data that is collected by the EPA from the operators. This is a sample form. It's the well monitoring report. They would be required each year to give a monthly total of what the average pressures, either both maximum and average pressures and volumes of liquids, brine, and such, disposed into the down the well. They also required periodically to do analysis on pH, total dissolved solids, TDS, and specific gravity. The information we get back from the EPA through the FOIA documents, usually it's from their database, occasionally it's their PDF documents, but usually the best thing about it is the spreadsheet will give you some ID information with company, well name, well number, latitude, longitude, and depth intervals and formations. What do you do with that type of spreadsheet information? You should make a map. That's why I'm here. In March of 2012, we actually got a first FOIA from the EPA on some information. Said we didn't really know what the status of some of these, which ones were active, which ones were inactive. The following, that year, we made our first attempt to make a small page-sized document. We actually, the following year, published our first Class 2 brine injection wells It also included in there some class 1 waste disposal wells, but that's not the focus of this talk today. That's the map up on the upper right corner. That's just a shot down version of this poster map that we produced in March of that year. About a year and a half later, we got another release of data from the EPA of all class 2 wells in the state. And then that included all the 2,000, almost 3,000 ERI wells, or the enhanced recovery injection wells. And that's on these lowermost, on the left, is an actual online map service that we developed that in. Because we decided at this point, instead of going paper, we would go digital, because, you know, if you try to build a database from that, you can't really display that in table form as the first illustration was. This is the blow-up of that map service that's created from the inclusion of these 3,000 other wells. And the takeaway thing here is to see that the red dots and the blue dots represent on this map service the different types of class 2 wells. The waste disposal wells and the saltwater disposal wells, the SWD wells, are red, and there's 152 we've been able to document and to follow. Of those, about 63 are actually active. The rest are either shut in or plugged and abandoned. Of the blue dot locations you see, there are about 2,900 of them. And as you can see, they're focused in some of the same areas that, you know, that some of the saltwater disposal wells are located. And the takeaway on this is, I said previously that there's 80% of the class 2 wells were from ERI, but in this case, and for Kentucky's case, that's almost 152 versus 3,000. That's only about 5%. So 5% of all class 2 wells in Kentucky are saltwater disposal wells. This is a blow up of just one area of the map to show you some enlargement of that. And within that legend over on the far left side, you can see how the wells are documented and identified. Whereas you can see a lot more blue on this particular map. And this is a big sinking water flood area where you can see, you know, hundreds and hundreds of wells, of which there's a few interspersed red saltwater disposal wells. Within this map service, we can actually tap into the database. Click on a well, you actually will be able to then bring up a pop-up on what's on this image on the far left-hand, right-hand side, and we'll scroll down and read through and connect to the oil and gas well database further down the menu. There's also tables on it that are accessible at the bottom of the screen there. You can see for the table, they've also showed the database that is connected to. Okay, now I'm going to move on to the brine disposal framework itself, since this was actually the lead-in to some of the work that I had done prior to that. It was just, you know, it was demonstrated that we had seen a very large increase in need for disposal wells because of all the rise in the horizontal drilling. It had been going on in the last 5 to 10 years with the Marcellus and Utica, Point Pleasant work in the northern Appalachian Basin. You see some of these major players. We've just seen NETL and REPSI represented as they are the partnerships that we worked with in this particular project. The major subcontractor was Battelle, and they worked with the state surveys of Kentucky, Ohio, West Virginia, and Pennsylvania. Marty and I worked on it, and it was a 2-year project, as I said, from 2013 to 2015. The objectives, you can see, are basically to assess the brine disposal of the northern Appalachian Basin. You can see the geological framework was what we were going to work on. You can see the 4 states, Pennsylvania, Ohio, Kentucky, and West Virginia. Those are where the horizontal wells are mostly seen. Our major tasks were basically collect data, do some geomechanical testing, and do model simulations, and develop products What did Kentucky contribute? Well, we did three major tasks. We gave samples from the recently drilled Hanson aggregates, number one Hanson aggregates drilled in 2013 from Carter County, from Rose Run to Copper Ridge and Mount Simon. We went through the administration and the operations data from the information that EPA had sent us for the pressure and volumes of data for wells that had been identified as saltwater disposal wells, and we documented 30 active wells in eastern Kentucky of the North Appalachian Basin, and reported on 21 wells that had actually had volumes of information. And then we ran the geocellular and then simulation studies for one of the 4 different formations that Patel had decided they wanted to do modeling on. Kentucky's case study was the Weir Sands in LA County, and we created maps in the cross section to supply them. Last slide. The actual project itself is found. You can find a report at the REPSI report at the REPSI website. It's fairly easily found. You can go there, and it's under the unconventional resources web page that they have. The major thing that you see with respect to saltwater disposal wells in the overall Northern Appalachian Basin are 324 saltwater wells that have been identified as having active permits as of August of 2013. Ohio had 2/3 of them at 211. They have a large commercial brine disposal network going on there. West Virginia had 76. Kentucky, as I said, had 30. Pennsylvania has 7. The monthly volumes, the operational data that they had pressure and volume on amounted to about 200 of those that were actually had data that indicated to us from the information there was 9 million barrels of brine injected. It increased from 9 million to 18 million by 2012, and most of that's been attributed to shale gas activity. They identified 10 zones that you can see over here on the one of those little insets there, all the way from the shallow Pennsylvania into the Duquesne area. They suggested as much as 10,000 barrels of brine disposed of per BCF, and the long-term demand for the proposal for brine disposal could be on the range of 700 million barrels to 2.3 billion barrels. And basically, that says that there is hopefully enough depleted oil and gas reserves at reservoirs and deep saline formations offer enough capacity for brine disposal. Thank you.